The next type of examples what we are going to discuss related to the correlation coefficient, that is R, as well as lines of regression. The other type of problems, as if you compare, it is different from the previous ones in which we directly calculated the coefficient of correlation and lines of regression. In this particular example, you will be provided with the lines of regression. In the previous one, the data for x as well as y is provided, and from that we try to calculate the values of capital X, capital Y, which are called as deviations from their mean. And then as per the requirement of the formula R, we calculate the coefficient of correlation and equation of regression line y on x as well as x on y. But in this particular problem, we are provided with the lines of regression, and from that certain requirements are to be obtained. So two lines of regression are given by 8x minus 10y plus 50 plus 66 is equal to 0, 40x minus 18y is equal to 214. Sigma x square is equal to 9. Sigma x square is equal to 9 means it is a variance of x, right? Sigma x is called as standard deviation of x. Sigma y is called as standard deviation of y. Sigma y square is called as variance of y. So in this case, apart from two lines of regression, they have given sigma x square is equal to 9. Then find mean values of x and y. Mean values of x and y means I have to calculate x bar and y bar. Coefficient of correlation between x and y means R. Standard deviation of y means sigma y. Sigma y will be calculated if you have the value for sigma y square. So all these quantities are to be calculated from the information which is provided. Now, in this case, two lines of regression are given by 8x minus 10y plus 66 equal to 0, 40x minus 18y is equal to 214. Now, we know that there are two different categories of lines of regression. One of the category for lines of regression is x on y. Other category of lines of regression is y on x. Now, in the previous problems, whenever we used to solve, we were very much clear that the formula is y minus y bar is equal to summation xy upon summation x square into x minus x bar, which will represent y on x. Similarly, the other formula will represent x on y. But from these two particular given lines of regression, how to identify that which must be the regression line y on x and which must be the regression line x on y? The rule is, or the thumb rule is, by observation, how to determine whether which line is regression line x on y and y on x. Usually, in whichever line the coefficient of y is greater, we consider that equation as line of regression y on x. Similarly, in the equation in which coefficient of x is greater as compared to coefficient of y, that will be mostly considered as regression line x on y. I repeat, in whichever line we observe that coefficient of y is greater than x, we say that it is regression line y on x. In whichever line we consider or see the coefficient of x is greater as compared to y, we say that it is regression line x on y, because that depends on the coefficients. Also, after doing so, we will check whether one of the product of regression of product of regression coefficient should not be greater than unity, it should be lesser than unity, right? That is what the property of regression coefficients we have. So from the given lines of regression, we will be usually trying to identify that which one is y on x and which one is x on y. But before that, whenever we have to calculate the mean values of x and y, how you calculate the mean values of x and y? Mean values of x and y are given by x bar and y bar. That means the quantities x bar and y bar are to be obtained. Previously, in one of the theoretical or explanation part, we have seen or we have written in the note, these regression line intersect at x bar comma y bar, or these lines passes through x bar comma y bar. So considering these lines as it is and assuming that these line passes through x bar and y bar, whenever these lines will pass through x bar and y bar, that means x bar and y bar satisfies the given equation. And when I say that x bar y bar satisfies this equation, means instead of x bar will be written, instead of y bar will be written, and solving them simultaneously will give us the values of x as well as y, the mean values of x as well as y. So very first beginning of the solution is, since both the lines of regression pass through the point x bar comma y bar, because we say that they intersect, so where x bar and y bar are means of x and y respectively. This is in lines of regression we have written, these lines passes through the point x bar comma y bar, means one of the point of intersection of the lines is x bar comma y bar, means it satisfies the given line of regression. So both lines of regression pass through the point x bar and y bar, where x bar and y bar are means of x and y respectively. Then we will be satisfying this particular equation of line y by x bar and y bar. So 8x minus 10y plus 66 equal to 0 becomes 8x bar minus 10y bar plus 66 equal to 0. The other line is also satisfied by x bar and y bar. So that equation becomes 40x minus 18y minus 214 equal to 0. Solving these two equations simultaneously on the calculator by putting the coefficients of x, y and constant respectively, calculator will give you the value of x, which will be our x bar. The calculator will give you the value of y, which will be correspondingly our y bar, because our equation contains the notations x bar and y bar. So we try to find out the values of x bar and y bar by using the philosophy or the concept that these lines of regression will pass through x bar and y bar. So my first quantity which is required, x bar and y bar, is calculated, which are nothing but the mean values of x and y. So what is mean value of x? X bar given by 13. The mean value of y bar is given by 17. Now I have to determine the regression coefficient. You remember we have written the formula A1 and B1. A1 is nothing but R into sigma y upon sigma x, which is acting as regression coefficient of y on x. B1 is nothing but R sigma y x upon sigma y, regression coefficient x on y. The product A1 B1 is nothing but R square. So R is under root of A1 B1, which is geometric mean of the regression coefficients A1 and B1. I am interested now in calculating the regression coefficients A1 as well as B1. So accordingly, the equation of line of regression are, now which line is to be considered for y on x? In line equation, whenever we have the coefficient of y greater than x. So here in coefficient in this particular line, coefficient of y is greater as compared to coefficient of x. So approximately we will go ahead with consideration that this is the line of regression y on x. Later on, after doing so, we check whether r is between -1 and 1. If it is, then our assumptions of regression coefficients or line of regressions will be correct. Else, we will have to change our assumption, right? So looking at the first rule, that coefficient of y is greater, correspondingly 10y is equal to 8x plus 66, divide by 10 so as to get the line of regression expressed as y in terms of x. So what I do over here, I transfer this minus 10y on the other side. So क्या बनेगा? 10y is equal to 8x plus 66. Divide by coefficient of y throughout. So y is equal to divided by 10. 8 upon 10 is 0.8. 66 upon 10 is 6.6. So whatever is coefficient of x will be a1, it is treated as regression coefficient y on x. So coefficient of x is a1, which is 0.8, is the regression coefficient y on x. Also from the second line, compared to coefficient of y, coefficient of x is greater. So 40x is equal to 18y to be shifted, minus 18y will become positive 18y plus 214. Divide by coefficient of x on both the sides. So it will be 18 upon 40y is equal to 214 upon 40, which is giving you x is equal to 0.45y plus 5.35. Coefficient of y in this equation will be nothing but b1, called as regression coefficient x on y. So once you get a1 and b1, we try to find out coefficient of correlation r, which is under root of a1 b1. When you take under root of a1 b1 and that value is lying between -1 and 1, that means our assumption of lines of regression is correct, and in turn the regression coefficients are also obtained correctly. So we know that r, which is coming out as 0.6, which is less than 1. So chosen lines of regression y on x and x on y are correct. If r greater than 1 is obtained, chosen lines of regression are incorrect. In such cases, we interchange the lines of regression. But here we have obtained the value of r, which is under root of a1 b1, that is correct, and hence we can go ahead with the assumption whatever we have taken. That first line, whatever contains the coefficient of y greater, is y on x, and second line in which coefficient of x is greater is regression line x on y. Correspondingly, after getting regression coefficients a1 and b1, we have obtained the coefficient of correlation. Now second quantity is also obtained, wherein we have to calculate coefficient of correlation. Third is standard deviation and variance for y. Now take any of the formula. Either you take a1 or b1. a1 is equal to r into sigma y upon sigma x, right? Or b1 is equal to what it will be, r into sigma x upon sigma y. Any one of the formula you can take for the calculation of the remaining part, that is variance and standard deviation with respect to y, because sigma x square is given to us. So from the formula, a1 is equal to r into sigma y upon sigma x, which is 0.8. a1 is nothing but 0.8, which we have calculated. So r is known, sigma y we have to calculate. Sigma x is square root of sigma x square. So what is sigma x square? 9. Square root of 9 is 3. Positive square root of 9 is 3. So sigma y will be a1 into sigma x upon r, which is 0.8. So 0.8 into sigma x is 3, r is 0.6, which is obtained as 4. So sigma y, which is standard deviation of y, is obtained as 4. Sigma y square will be 4 square, which is 60. So in this case, all the requisite quantities are obtained, wherein we have mean values of x as well as y, correspondingly called as x bar and y bar. Coefficient of correlation is obtained from a1 and b1. From any one of the formula, we calculated standard deviation of y and variance of y. So this is one of the important examples